And welcome back to another episode of the Game Engine series. Event systems. We're finally building ours. I know I've promised this for the last couple episodes, but we're finally there. We're finally going to start working on it. And I actually think this was quite an exciting episode. I think it's the most fun code we've written so far, in my opinion. Sure, nothing on the screen is going to change, but by the end of the episode, we're going to be able to see every single event that happens. So we'll be able to log mouse movement, mouse clicks, any button on your keyboard being pressed, all that kind of stuff. We're going to start to handle this episode. So my goal of this episode isn't to build the entire event system, entire input system, but it's just to create the building blocks. So what we're going to do is, one, we're going to start our application abstraction. So I know there's been a lot of abstractions recently, last couple of episodes. This one, it isn't abstracting code we've already written. It's going to be new code, but we're just going to, right off the bat, have it in a nice abstraction so we can kind of hook into these events. Because at the end of the day, GLFW is giving us events, but we want our application to be able to handle it. So yeah, I hope this is exciting, and I hope anyone that's been following along is just enjoying the series. I've been having a lot of fun with it. I've also just been enjoying developing the full game engine itself. I've been doing quite a bit lately, so I really encourage you to go check out the code, go run it. You should have all the tools, everything set up to be able to run it. If you have any problems, open up a GitHub issue or anything like that. And of course, if you see any areas of improvement in the code, open up a pull request. If you want to change the code that we're doing, it's the YT branch. But if you just see code improvements in the main branch too, definitely feel free, open up a pull request and just let me know. I'll definitely be reviewing it. I'll give my feedback. And if it's good, if it's going to work well with the code base, absolutely, I'll accept it. So yeah, I highly encourage that. Link's down in the description. Let's get into the code. And we're back in the code. So let's just, again, run last time. So we have our new logging system. So starting up, you can see we have our window and then shutting down. That's what we did last time. We can come back to the code and just get started. So what are we doing? We're going to work on our event system. So what do we need? Our different kinds of events. So let's, inside of core, create event.zig and get started. So just starting with some imports, C as always, and same with C. This is pretty standard for us by now. C.zig, and we'll need GLFW and glad. GL equals C.glad. So we're going to start by defining all the different buttons and keys. So let's start with our mouse buttons. Const mouse button be an enum of U8. And then we'll just define a few. So we have our left mouse button, our right, our middle, and then we'll define some extra ones, as it can either be the side buttons on your mouse, it could also be controller buttons, anything like that. And we're just going to define for now 7. This can be very easily extended in the future. And 7. So one thing I do really want to write as much of the code as I can with you guys, but this is going to be one very tedious thing. So there's just going to be one thing I copy and paste, and it's essentially just a conversion from GLFW events to our own defined events. So I'm going to paste it in right now, and we're going to take a look at it. So it's going to be pretty similar, enum, but this time U16, but now we're essentially mapping every key on the keyboard. So we're going to have space, apostrophe, A through Z, F keys, all the special keys, everything like that. Again, I highly encourage you to look at the code down in the description. It's in there in the event.zig file. And then what we're going to do is on that enum is create a from GLFW, and then it's just going to map from GLFW to our type. And this is the only code I'm going to paste. We're going to keep writing after this, but it's very tedious. It'll take a bunch of time. I don't discourage anyone from copying and pasting this code. It maybe write the first few yourself to understand, but it's all in there. And let's just keep going. So now we have all the keys and buttons defined. Let's define the actual event. So it's going to be one more enum. It's called the Z event for Zephyr event. It's going to be a union enum. Nice, because an event can take on a bunch of different forms that require different data. So that's why it's a union enum, because we can have, it's not just a normal enum, as we'll see. It'll have either structs or keys or buns. It'll make more sense in a second. So first one can be window close. This is really just a type. And then window resize. And here we're seeing why we're using a union. So we can do struct width be a U32 and height C32. And then it's not window, but frame buffer resize, because frame buffers and windows are a little different. This is most important for actual when you get to the editor, which we'll see later. Same with content scale. But these are all different events that can happen. So let's include them. F32 and F32. So we have key pressed, which is the key that we just defined above, key released, which is a key, and key repeated. The key, and then char input. This will be the char kind of callback that we have, which is, it'll handle like exactly what you press on your keyboard. So if you do like Shift A, it'll put A in this value, or if you do like a semicolon or a colon, it won't be like Shift plus, it's just gonna be the actual thing that you press. So good for text inputs. Now let's move on to the mouse. So we have mouse scroll, which is F32, F32, and then mouse move. Same thing. 32. Now we have mouse pressed, which is the mouse button we defined at the top, and same with mouse released. Nice, and that's all the different types of events we're gonna have. Now let's keep going. We're gonna move on to the actual GLFW callbacks. So first we're gonna write a nice helper function. Function get window from GLFW. We'll take that C window and return a pointer to our window. So that's one import I forgot. Window. So all it's going to do is the pointer, GLFW, get window user pointer, and we'll see where this is set very soon, and return kind of some cast now, because it's just a raw pointer, so we want to put it to the proper type by aligning it, casting it. And we're going to use this a bunch. So we're going to start with the kind of beefier callbacks and then move to the smaller ones. Let's get going. So pub function mouse button callback. We'll have that C window, so the GLFW window, button, which is C int. And this signature has to match because this is called directly in the C GLFW code. So we're not really defining this as ours, but instead we're gonna register and pass it to GLFW and then mods. And that's why we need this call conversion to C, because it's called by C code. Now we don't actually need mods for this one right now. And now there's only two types of events we care about. And its action is GFW press and release. Release. Nice. So if it's not either of those, we can just return. And now same, because remember we only registered 7 buttons. We go back here like 0 through 7. So let's just do a quick check to make sure we're not getting any bad types. And again, we can extend this in the future. We can even add logging here if you want. You can add some debug logs to see if we ever run into this. But for now, it's okay. So now we've done our validations, we can get that window using the function we just wrote. And now we're going to convert. So const button can be this mouse button. So we can do enum from int, kind of do some casting here of the button, because remember we're getting it as a cint. Going back to the top, we get button as a cint, so we have to do some casting. And now we can create the event. Z event. So if we had press, we know we want Z event mouse pressed is this button. Else Z event of mouse released. And I misspelled that. So let's go back and fix that in 1 second. Mouse released. I think this may be, yeah. There we go. Next, this is the last line, and we haven't written this yet, but we're going to dispatch the event. So what does this mean? Well, now that we have our event, our Zephyr event, we've created it, we know what type it is, we need this to kind of push through to our application. What does this look like? Well, what we're going to do before moving on and writing the rest of the callbacks, we're going to first add this function and a register event callback function inside of window, which we're going to do that right away. And then we're going to create our application, which has an on event, and we register that with the window, which then dispatches here. If that doesn't make sense, just follow along for the code, and hopefully as I explain it, as we walk through the code, things will make more sense. So let's head over to our window, and we can start by writing that function. So we're kind of working backwards here, but I'm doing that in a way so we can see call by call where we're going. So that we called it dispatch event. And it's going to be to our window and event.z event. I think we need to actually import event here. Import event. So we have the event, and this will just be void. So we're going to add this event function that isn't defined yet, but we'll store it and take an event context and the event. Again, event function and context aren't defined yet, but we're working backwards, so that's next. So now when we head back to our window definition, this is where we're going to define it. This is probably going to be the most complex code that we've written so far, just because it's quite hard to define passing functions around and doing that in Zig. It doesn't look very pretty compared to some languages, especially if you work something like JavaScript where you're constantly passing functions around, but it's how we do it in Zig. So we have that event function. So how we're going to define is const function. And the first one is going to be any type or any opaque. And the second one is Z event. So if you remember, when we defined that dispatch event, we had the context and then the event. So the any opaque here is that context, and it was also void. And for now, it's going to default to undefined. And then we'll define the context. So any opaque, so it'll be any type, and also start by undefined. Those should be commas. Next, we need to actually set this data. So let's create a new function. Let's set event callback window, and then we'll have that context. In this case, we can use it, the actual any type. And then we'll want the same kind of function definition, but we can keep it a little bit more tightly scoped with comp time. So we can do it the type of the context to enforce that, and then the event void, this function is void. Let's just zoom out while we write this a little bit, just so we can see. But I hope this is kind of making sense. So we're going to have our self, that context, and then our function is the type of the context and the event. So again, when we look at that, looking down at dispatch event, we have that context and event. And if we look at going back here to dispatch event, we see window dispatch event. So we can do that because the window stores the context. So all we need to do is we've created an event. Let's push that to the window. And then the window is just going to call whatever function it has stored. And context can be anything. In our case, it's going to be the application. I did this in a generic way so that when we get to our editor, it can also plug into events. So really, by having this, we can create multiple windows and have different applications plugging into events. Let's keep going. So let's get the context type just for ease. Type of context. Now let's define it. Again, this is where Zig gets a little weird because you can't just do like event function equals callback because they are different types. So you have to do some extra casting and some extra work to get it to work because this won't compile. So it's actually going to have to define a struct with the dispatch function called .dispatch right away. So you're kind of just, it's kind of like an overlay of dispatch, which we just pull right away. So now we know it's going to be that any opaque, because that's again how we have it stored. Right up here, we have it any opaque, and then z event. Z event. Nice. And now we can call that callback function. And then we can cast. And again, this is kind of getting messy with because it's all pointer functions. We have to do all of this. But now we have the callback. We have the context properly casted as the context type. And then we're passing through. So now we have a function definition bound. And of course, we also want event context equals context. In this case, it's not a function, so we can just do that after a cast. Now I'm going to do one thing that also should help shed some light with this. We see we get window user pointer, and we end up turning it into our window struct. Well, how do we know this? Well, this window, we can actually kind of set a global context in GLFW. So we do GLFW set window user pointer, self.window, again, that's the GLFW window, and then pointer cast to self. What we've just done is set user pointer to ourself, which is our window struct. So now that that's set inside of event, we can just pull that at any time. We just have to make sure it's called first. Okay. Like I said, we're slowly working backwards. So now one last thing we have to do before we keep moving on to the different events is going to be our application. So let's write that. So we're going to go into core, do application.zig. So now we can get into it. Again, we're going to do all the imports as always. std equals that import std and glfw equals that import. In this case, we don't need glad, so we can just do .zig glfw. Nice. So now let's keep moving. Window. We need the window and the params and really everything. Equals window params and window equals window. And const event at import event.zig. Nice. So then for now, we really only have one type of error. We're going to keep doing the same error handling as we have. Window error. And then I guess we also have, I think it's out of memory. And then we do pub const application, just as we've done with other things. I know this video is going to be pretty long, but that is what I thought it would happen with the event system. It's quite beefy to get going, but it's definitely worth it. Allocator. Now we can do our init. Again, should all seem quite familiar. Allocator, params, window params, and then it's going to be application error, pointer, application. I'm going to do window equals window dot init, allocator, params, catch error, just as we've done, std log error, failed to initialize window. Error, and then return application error, window error. So now we have our window. Now let's create our app, which we can use try because it only does the application error. And I'll see if I can explain that right away. So we look at create, it has an error, but all of it's only out of memory. So if we define out of memory in here, we can use try and then still properly set everything. So app.star equals, let's get that. Put the actual data in, allocator, allocator, window, window. And return the app. Nice. So now we get to our actual setting event callback. So we have a little window. We can call our set event callback an app, and then we haven't defined this yet, but it will be there. So now I hope this is making more sense. Our app is going to be the context. So all this kind of messy, like any type, any opaque context is our application. And then the event function is this event callback, which we're going to write right now. So pub function event callback, and it's going to follow that exact same pattern. Const application ev event c event void, and I'll fill this in, but for now let's just do log info event, do tag name the event. Then we will use self eventually, but not for now. Okay, so now we registered this callback, which is the type of context, which is our application and event. So now we can see, we know app, so application, these match. So when we go here, we know this kind of pointer cast, that any type we pass is going to be the same here. So now we've registered this. So our context, this is our app and event. So now there's, as we write our callbacks, there's going to be two things we continually do. The first one will be defining it here. So we actually finished our first one. We go back to event, we have our mouse button callback. So we can start actually seeing that happen. We can do underscore equals GLFW set mouse button callback to our self.window and event.mouse button callback. And we're not going to define any of that, but now we've set that callback. Nice. So now that we've done all that, we need to actually switch our window to using application. So if we go over to root, we see we have window right now, but actually what we want is application. So let's do that. Application equals import core application. So now we have application here, and the params are really the same. Instead of that, we can say application init failed instead of calling this window called app. Oh, and I guess we should actually finish filling in application. It is just the dinit that we need. So pub function dinit self pointer to the application, self.window.dinit self.allocator and self.allocator destroy self. Nice. So we can go back over here and do app. Now we just have to do app.window and app. And one mistake made would be window params. And then another mistake is this no longer needs an allocator pass to it. So now if we run it, look, if you click your mouse, you can see mouse press and mouse released. That's pretty cool. We have mouse press, mouse release events. And just like that, we have our event system up and running. So the remainder of this episode is just going to be hooking up every kind of event. You can speed along, you can copy the code after. If you want to stick along for it, great. But that is our event system. We have the entire flow done. Now it's just all about adding all the different kinds of events. Nice. So now we can do our key button callback. And again, all these will have pretty big parameters, but or definitions. But it's just how GLFW wants it. It has to be exactly as GLFW expects, or it won't compile. Cint and call com.c void. Zoom back in again. Now we don't need mods or scan code. And now we have win equals get window. And then we can use that key. And you can see why I didn't want to write this all during this episode. It's already a long one, so I hope you all have that. And if map key equals unknown, that's not good. So log dot warn found unknown key code and then key and return. But if not, we can just start getting the event. Was undefined. If action equals GLFW, GLFW press, then we know we have the key press. Else if the action is key repeat, then we know we have a repeat. Key repeat, EV equals the event dot key repeated, map key, and then else if action is GLFW release, then we have the release event. Key released. Nice, and then we can just dispatch that event, just like we've done in other places. So now let's keep going. Let's go over to the window resize. On one other thing I did want to add to window, which should just make it a little bit easier. Pub function set size self window width height. And it's void and self data width equals width and self data height equals height. Then we go back over here and let's keep going. We have our pub function window resize callback window c.window width cint height cint callconf.c void. So now we can do const win equals get window from GLFW window, and when we do that, set size width and cast height expected. Oops, just not proper parentheses. And now let's create that event. ev equals the event window resize dot height int cast height and width int cast width. And we just dispatch the event. I just find that part be the most satisfying to write. So now we're gonna have a very similar one, but this one is frame buffer size callback. I think it's all the same parameters, but instead of doing set size, we can do viewport. So this will properly set the viewport as we resize. Be width and height. Instead of window resize, let's do frame buffer resize. And now we have the content scale change, which again, we're not using this one right now, but it will be used later. C window, scale, F is 32, F32, and F32, callconf.c void. Very similar stuff. Equals get window. And then the event is content scale change dot x is x scale and dot y is y scale. And window dot dispatch event ev. There we go, just missing a dot. Nice, and then we'll define the next one. Window close. Callbacks, this is when we close the window. Callconf.c void. Same as everything. This one's an easy one. C event equals dot window close. We can dispatch that event and all the cursor, or two cursor in the char. The function cursor pause callback c dot window x. These come in F64s, but we'll convert them. Callback.c void const window, use get window from GLFW window. Again, all of it very similar. C event, mouse move, X, floatcast, X, and Y, floatcast, Y. Then dispatch the event. And now instead of pause, it's going to be scroll. But everything else is pretty much the same. Just mouse scroll. Then last one. Char, not chat, but char callback, window, c dot window, code point, so satchel, uint, welcome.c void. Now get the window. I hope this is exciting for you guys, because once we register all these, then it's all the events, and I'm gonna add all the logging in this episode just to show you, because it's pretty cool. And then dispatch the event. Okay, so now we've done all of that. Let's go over to window. Okay, we've done that. So now let's go register them all. GLFW, let's not forget that. Dot GLFW set key callback, self dot window, and event dot key button callback. And again, make sure you are just defining the functions and never calling them. GLFW set char callback, self dot window, and event dot char callback. Then I'm gonna go paste the rest of these in here, and I encourage you all to type it. I know I said I was gonna do all of it, but this is all very repetitive. So we have window size, frame buffer, window content scale, window close, cursor position, and scroll. So now one thing I will write is, well, let's just start by running that. See if we have any errors, which we don't. We can see mouse move, mouse clicked, keyboard pressed, released, the char input, all of that. Window close, but I want to show more data. So now if we go over to our application, let's do that. So let's do a switch on the event. And now mouse move, mouse event, and then log info, mouse move, x equals that, y equals that int. And now we can do mouse event.x and mouse event.y. So right now, I encourage you to try and do the rest of these. So I'm going to paste these in for anyone that wants to look at it. We can get rid of this. Just zoom out a bit. But this is it. We can see them all. So take a second, get it all there, and now let's run it. And now we can see as our mouse moves, we get all that data. We get key pressed. The key is A and it's released. We also get the char input in case you want a buffer. Now if I just go ahead and type on my keyboard, see everything I'm typing, and again moving, and then you always get the window close. I know that was a lot of code, but proud of anyone that's stuck with it. I think this is a really exciting thing. It's needed for a game engine. We need to know all the events. And I tried to do it in a way that's very extendable, very reusable. And I hope you enjoyed the video. So like I said, I think this code was a lot more exciting than what we've done in the past, but I hope you can see how all that work we've already done just helped make it quite easy for us to do. I know there's a little area where the code got, I wouldn't even say messy, but just more complex, because things like passing functions around can be a little messy in Zig. That's just the language, the type definitions, casting, rules. So I know it got a little weird, a little annoying, but I hope you stuck through it and got to the end, because I think it's a pretty clean solution. I think it's very clear how we can just register our callback and have all our events passing through it. And pretty soon, once we get to scenes and our sandbox app, you'll see how this application event, on event function, is just going to handle passing all the events through the scene, on updates, on event callbacks. So that's coming up next. It's going to be very soon. Like I said, I think next will probably be input system, but then right after that is scenes and sandbox app. And if you don't know what I mean by sandbox app, we're running a game engine, so we have to start being able to develop an actual game. So the sandbox app is kind of gonna be that game for now, but we'll also turn the sandbox app into the actual editor. Because realistically, the first game we're making is our game engine, or the editor for the runtime. So I hope that makes sense. I think it'll be a lot more clear in the future once we start working on the editor, but that's all I have for today. As always, Twitch links down in the description, Discord links down in the description. Please come say hi. I've really been enjoying talking to you all on Discord. So yeah, I hope you all have a great day and look forward to the next episode.